Hello everyone. Hello everyone, welcome to today's class. We'll be continuing with our differentiation, and today we are going to look at logarithmic differentiation. Means we'll be taking help of log to ease the differentiation. Let's see first of all why is this helpful and how can we use this. For that we need the properties of log. So first I'll discuss the basic properties of log. What does it mean and basic properties. Let's first understand the sense. Suppose it is written log 2 base is 2 8. What's the value? In order for this to understand, think a power of 2 which results in 8. Okay, that's your answer. Log base 2 8 is 3. Power of 2 which gets you 8. Okay, now think like this. Log base instead of 2, let's take 3. Base 3 3. So 3 raised to power what? What can you raise the power of 3 so that you get 3 also? So that's 1. Okay. Now further you can think like this. Log, let's say base is e. Okay. E is some number. We know E is Euler's constant and it is 1. So what will you raise the power of E? Means E raised to power something should be 1. What should be that something? The answer is 0. Okay, and interestingly log 1 is always 0 whatever base is, because anything raised to power 0 is 1. Okay, this is how you have to understand log. Means what should be the power of base so that you get the number written here. Okay, now let's see one more thing. Log, let's say base is m. Okay, this is y, and one second. Let's say log base, this is x, this is y, this is z. Okay, log base x. Why it's not working? Log base x y is z. What does that imply? It implies that x raised to power z is equal to y. Okay. Now in mathematics we consider log base e x as our log x. Remember that. Okay. That log base ex will be log x. So we'll not be writing base specifically. If nothing is written, assume the base to be e. Okay, and right now we are not bothered with this log anyway, because most of the questions are directly given in terms of log. Now the basic properties of log, let's see that. The first property is log a plus log b is log ab, and in this particular differentiation, logarithmic differentiation, we'll be using this in reverse. Means multiplication can be broken down in addition of 2 logs. Similarly, log a minus log b is log a by b. Okay. Third, log a raised to power n. Suppose power is n. Okay, you can rewrite this as n log a. You can take down the power. Okay, and e raised to power log x is nothing but x. E and log, they can cancel each other. Basically they are sort of inverse functions, so they have the ability to cancel out each other. You can think of this like square root has the power to cancel the square. So square and square root, they can cancel and we get x. Same kind of thing. Okay, so these are the basic properties. If any other properties comes up, I'll add it here. Okay, let's see the question now. I'll start with the basic. What is the purpose? First of all, we have to decide when to use this method. Okay, so majoritively I'll recommend this to use when variable raised to power variable is there and you have to differentiate. Okay, when the variable is present in the base as well as in the power, use log. Else you have some sort of nth root or any square root and you have multiple terms inside it. Okay, then also you can use log. Okay, that's basic idea. Now let's see the question. Y is equal to x raised to power x. Find dy by dx. So you can clearly see here variable is raised to power variable. So the steps involved are take log on both sides. So log y is equal to, you can rewrite this as log x raised to power x. In the log we have the property whenever the power is raised we can take down this power. So basically log y is x log x, and now at least the power is not in the variable is not in the power effectively. So now differentiate both sides. Okay, so let's see. Log y differentiation, it will be same as the differentiation of implicit function. Whenever y gets differentiated, you add or you multiply y dash additionally. Okay, so because of the chain rule, so log y differentiation is 1 by y into y dash is equal to, and here while differentiating you'll use uv, two things in multiplication, uv. So differentiation of x 1, differentiation of log x as it is, plus differentiation of log x, that's 1 by x into x. So y dash upon y is equal to log x plus 1. So y dash is y log x plus 1. What was y? From the question you can recall y was x raised to power x, so you can replace it. So this is x raised to power x log x plus 1. That's your answer for y dash. This is the power of log. Whenever you have variable raised to power variable, you can easily solve these kinds of questions. Okay. Let's see one more. Let's look at this. So now again this is your function and you have to find, this is suppose y, find dy by dx. Okay. So you have to differentiate with respect to x. You can see they are getting multiplied and the power is also 2, 3, 4. So weird kind of power. Now let's see how log can help you. Whenever you have like weird power and multiple expression, I told you like whenever you have square root, as such I just erase this, like this or like this. Multiple terms with multiple power, a, b, c, multiple powers. Okay, like this also. So this question, let's take log both sides. So log y is equal to log of x plus 3 square, x plus 4 power 3 x plus 5 power 4. Okay, they are getting multiplied. It's like a, b, c. In multiplication, we can break down log as in addition. Okay, so log a plus log b plus log c. So this is log x plus 3 whole square plus log x plus 4 whole cube log plus log x plus 5 complete raised to power 4, and use the property, take down the power, get the power down, get the power down, get the power down. So the problem was because of multiplication as well as the power, both are solved with the help of log. So 2 log x plus 3, 3 log x plus 4 plus 4 log x plus 5. Okay, so far this is your log y. That's it. We haven't even differentiated yet. Let's differentiate now. So differentiating both sides. Log y differentiation, y upon y dash. 2 log x plus 3 differentiation will be, 2 will be as it is. Log differentiation is 1 upon x plus 3, and the coefficient of x will get in multiplication, but right now the coefficient of x is 1, okay, in this. So you don't have to worry. I'll explain what I'm saying. Log x differentiation we know, 1 by x. So log ax plus b differentiation, okay, will be 1 upon ax plus b, and additionally you'll have a in multiplication. Okay, but right now there is coefficient of x is 1 in whole expression, so I have to just differentiate easily. So 2 upon x plus 3 plus 3 upon x plus 4 plus 4 upon x plus 5. You can see how this is simple, y dash upon y. Okay, so I can get y dash as y. What was y? Y was a complicated expression. Y was x plus 3. Take this y on the other side. Now x plus 3 whole square, x plus 4 power 3, x plus 5 power 4 in multiplication with 2 upon x plus 3, 3 upon x plus 4, 4 upon x plus 5. Now if you want, you can take LCM, solve it further. If I'm not going to solve it anymore, this is pretty much the idea. Okay, it depends what kind of options are given and what kind of answer is expected, but you can solve it further accordingly if asked. But this is the key idea. We have differentiated, we have found the y dash. Okay, all right, next question. Log cos x, that's your y. Find y dash, dy by dx basically. So you can again see variable, power variable, variable raised to power variable. So what we have to do? Take log. So log y is equal to log bracket log x raised to power cos x, take the power down, log y is cos x log bracket log x. Now this is something that we have done, function inside a function. Okay, function of function. We know we have to use chain rule accordingly. So differentiate now. Differentiate both sides. So log y differentiation, y upon 1 by y into y dash. Okay, cos x log x ub. Okay. So cos x differentiation minus sin x log x plus this time differentiation of log x. So I'm just writing it, I'm not differentiating, I'll do it in the next step. Differentiation of this log x cos x as it is. Let's use chain rule. You should be comfortable with it now. First function comes is log, leave it, whatever present inside, consider that to be your z. Okay, copy this. So log z differentiation is 1 by z into z dash into cos x. Put the value of z. Z was log x and log x differentiation, okay, cos x. What is the differentiation of log x? 1 by x. So 1 by basically x log x cos x, and this expression, okay, this we have to copy, minus sin x log bracket log x, this is y dash upon y. Okay, let's take y also on the other side. So basically y dash is y was log x raised to power cos x, na? So that will be in the multiplication of whole of this answer, sin x log bracket, okay, multiplication log bracket log x plus 1 upon x log x cos x, okay. चलो ये done, this is done. Now x raised to power x done, this is also done. Let's take a look at this question now. So you can basically generate infinite kind of questions. Questions can be formulated in any way. You have to get the idea when to apply it, how to apply it. Okay. Y is equal to this. Find y dash. The problem with this is, if first of all there is addition going on. So if you take log, let's say this is a, this is b, it will look like log of a plus b. The point is, after that you cannot do anything, because there is no such property that log a plus b is log a plus log b, because we know this is the property of log ab. So instead of directly taking log, what we'll do is, we'll do this question in 2 steps. Okay. For the time being, let's consider this part. Only take one part of it as u, another part of as v. I'm not saying it is ub. I'm just saying call it u, call it v, or any other variable of your choice. Okay, and let's say y is equal to log x raised to power x. Let's find u dash first and v dash, and then we'll add them. Okay, basically if y is this, okay, the idea is, if y is equal to u plus v, then y dash will be u dash plus v dash. All I need is u dash v dash, so I'll calculate them separately. So 2 times I have to do logarithmic differentiation, and I'll get the answer accordingly. Okay, let's see. So log u is equal to log x raised to power x. So let's take it, u, taking log both sides, so log u is equal to, now I'm doing directly, power will come down, log of log x. Okay, differentiate. So u dash upon u is equal to differentiation of x, 1 into log x plus differentiation of log x. So again we'll consider z. So just for your reference, log z differentiation is 1 by z, that means 1 by log x, into differentiation of z dash, that is log x differentiation 1 by x. This is something we have already done, na? Log x. Okay, 1 by x log x was this, into x cancels. So u dash is u, which was log x raised to power x. Take this u on the other side, multiply it with the whole answer, that's log x plus 1 by log x. That's it. This is only half part. Okay, same thing you have to do with the v also. Okay, so you can start, and you may pause the video and start doing on your own, and then verify with my answer whether you're getting the same thing or not. Okay, all right. Maximum, I think we can do one more step for this. What we can do is take log x as LCM. So log, oh, that will be complicated, looking complicated. It will be log x into log bracket log x plus 1. Okay, and this will be log x power x. You can combine the log x, bases are same, so power will get subtracted, so it will look like log x raised to power x minus 1. Inside it will be log x into log x. I know it's looking very complicated, but yeah, these are the kinds of expression anyway. U dash is like this. Okay, calculate your now v dash accordingly. V is x raised to power log x, so let's start it. V is equal to x raised to power log x. I'll do it quickly. Log v is equal to, power will come down, log x. Interesting. Log x. What we can do is we can write down this as log x whole square also, or if you want you can use uv also, your call. I'm going to do with this method. Okay, log v. So v dash by v is equal to, differentiation of this will be, consider the thing inside this as z. So z square, so 2z, so 2 log x into differentiation of log x 1 by x. So v dash is v, which is x raised to power log x into log x, 2 log x upon x. Again what we can do is still combine x raised x and x. Powers, bases are same, power will get subtracted, so x raised to power log x minus 1. Remember this is log x separately, minus 1 separate, not x minus 1. 2 we can write here log x. Weird looking answers. Yes, logarithmic differentiation has that. Okay, all right, now let's see something else. Let's look at this. X raised to power sin x raised to power cos x. That's your y. You have to calculate, find your y dash. Okay, fine. Again, same idea. You cannot directly use logarithmic because log cannot be splitted about plus. So what you can do is take this as u, take this as v. Okay. For the final answer of the previous question, you put the value of u dash, this long expression here, put v dash also from here to here. That's it. Means don't do anything else. That's it. It's a long answer, sort of a subjective one, but the idea can be projected in objective also. So just get the idea where to apply, how to apply. Get comfortable with that. Okay. So let's find u is equal to x raised to power sin x, u dash by u. No, sorry. Let's take log first. Log u is equal to sin x log x. U dash by u, differentiate, sin x differentiation cos x, log x as it is, log x differentiation 1 by sin x as it is. U dash is equal to u, which is x raised to power sin x. If you want you can take the LCM, same way in the last question, x cos x log x plus sin x, and then deal with power of x. That's x raised to power sin x minus 1, remember that, like this, into x cos x log x plus sin x. Okay, that's your u dash. Let's do v dash also. v dash is equal to so before that we need v is equal to sine x raised to power cos x. Okay, trigo raised to power trigo. Nice. Let's see how this is done. Idea is still the same. Take log v is equal to power will come down, you take log sine x. Okay, log v differentiation is v dash by v. Then differentiation of cos x is minus sine x into log sine x plus log sine x differentiation is, consider sine x to be your z. When you, while differentiating this, consider sine x to be your z. So sine log z differentiation 1 by z means 1 by sine x, and then differentiation of z dash means cos x, sine x differentiation is cos x into I think cos x was as it is also, no? That's it. So v dash is equal to v, which is sine x raised to power cos x into it's our call, we can take LCM of sine x. This will cos will become cos square, so let's write down cos square positive first, minus, if you take LCM it will become minus sine square x log sine x. Okay, space, almost done as such. Okay, log sine x. Okay, and then again maximum you can do is deal with this. I have written wrong here, once sine x raised to power cos x. So power you can deal, bases are same, so power will get subtracted. So that's sine x raised to power cos x minus 1 into this expression cos square x minus sine square x log sine x. Okay. We could have generated cot also if we wanted. Cos by sine was cot also. We could have gone by that method also. Again, if there is no restriction, again it depends what kind of question is asked. Okay. All right, we're done with this. Now let me see. Okay, now there is one more kind of question, like slight variation in it, very slight, but yes, it is there. Just look at the question now. That's your question. This is y raised to power x is equal to x raised to power 5, and question says find dy by dx. Now if it was only equation in x and y, we could have used the concept of implicit function also, but right now this is a equation in power also, no? Variable is in the power also. So what do? The moment we see variable raised to power variable, we have to think log. So take log both sides. So log y raised to power x is equal to log x raised to power y. Use the power form, get the power down. So x log y is equal to y log x. Now if you want to do this very quickly, you can get this log xy on the left side and use the direct form that I taught you for implicit, which involves partial derivative, or let's go with the standard approach, differentiate both sides. That takes uv. So fine, you do the uv one on your own. I'm going with the short one, and then let's see if we can get the correct answer. Okay. So what I'm doing is writing this x log y minus y log x is equal to 0. This is a function of xy, f we called, and then directly we know dy by dx is negative of partial derivative of f with respect to x upon partial derivative of f with respect to y. Short approach. Let's see. So negative of, while differentiating with x with respect to x, we have to consider y to be constant. So x is constant, sorry, y is constant. So log y is also constant, leave it. Differentiation of x is 1. 1 log y. Again, y is constant, leave it. Log x differentiation is 1 by x minus y by x upon df by dy. This time do the reverse. So x, leave it. Log y differentiation is 1 by y minus y differentiation is 1 log x, keep it as it is. Okay. In one step we got dy by dx. Now let's take LCM and just simplify it. Take the negative in both the expression. Okay. So you'll get negative outside. It is x log, my bad, negative common, x log y minus y upon x, and the denominator comes x minus y log x upon y. Just rearrange it one more step. So it will go in the numerator and reciprocal it. So minus y by x, x log y minus y upon x minus y log x. I can take this negative in the denominator and rearrange the term denominator to match with the numerator kind of thing. It is x log y, na? It will become y log x. I think that's it. That's the maximum they can manipulate. Again, it depends. If the options are given, you can always manipulate and get the answer. Okay. All right. They have manipulated the answer. So take this negative inside also. 1 second. Something is wrong. I took the negative common, should have written plus here. Should have written plus also here also. Then the answer will not match. Why that is not working? Have we missed something? Negative. Why have written negative? Oh, my bad. I put the wrong negative like this. This negative is with the complete term. This negative was with the complete term. So that was here with the whole term. I should have left that. That's it. I think now everything will get normal. This was x log y minus, this was minus y, that was correct. So that means this was minus was also correct. Now it's matching. Take the negative inside if you want. So y by x, it is coming y minus x log y, okay, upon x minus y log x. That's the answer. Yeah. So yes, the concept of implicit function, the direct method to get dy by dx, that's also working. Though I have shown multiple steps here to get to the final answer, you can literally get the final answer from this step. If you're good with maths, you can directly get that. There's no problem with that. Or you can go through the process of UV also. That will take slightly time, but again you can work it on your own. Okay. For this question, I'm not taking UV. Okay. And I'll recommend that unless and until it's a subjective question and you have to show your steps, don't do it. Use this approach. You have to be faster in maths. You need to learn these kinds of tricks. Okay. And this is not effectively even a trick. It's just higher mathematics. This will come to you, but at higher grades maybe. All right. Next, let's see. Same kind of thing. It's just that okay. Next question. This is the expression. Find y dash. Okay. All right. The moment we see variable raised to power variable, we have to consider log. So log cos x raised to power y is equal to log cos y raised to power x. Get the y down, get the x also down. Y log x, log cos x, trig is also involved, x log cos y. Okay, and now you can see why those kinds of questions will be helpful. Y log cos x minus x log cos y is equal to 0. Consider this to be your function, and now directly get your dy by dx is equal to minus differentiation partially with respect to x, differentiation of f partially with respect to y. And I'll write negative here so I don't make the same mistake again. I'll write negative here. So negative of, then let's start. Partially with respect to x, y is constant, keep the y, log x cos x differentiation. Now this will take time. So you'll have to differentiate log cos x and log cos y also. So let's differentiate log cos x because that will give you the idea of log cos y also. Log cos x differentiation will be, you consider, leave the first function, that's log, get the other one as z, then log z differentiation is 1 by z into z dash 1 by cos x, differentiation of cos x is minus sin x. I should directly say minus tan x. Okay, all right. So see, we are differentiating partially with respect to x. So if we have to differentiate partially with respect to y also, so we'll get same thing, instead of x we'll get y. Okay, so y differentiation into log cos x na. So log cos x differentiation is minus tan x minus x differentiation is, again we are differentiating with respect to x, so x differentiation is 1 log cos y as it is. Okay, that's differentiating with respect to x. Now differentiate with respect to y partially. So first y differentiation is 1 log cos x as it is because it's a constant, minus x will be as it is, log cos y differentiation directly say minus tan y. Okay. This negative will cancel these two. If we take that negative out, we'll get that cancelled, and clearly these two negative will also cancel it. So we should get a positive answer. That's y tan x plus log cos y upon 1. Why I'm writing 1? Directly to say log cos x plus x tan y. So you can see this time it didn't took so many steps because there was no LCM and anything else. Let's see, y tan x log cos y, x tan y, x tan y log cos x. Yeah, that's correct. How simply we got this. If you do UV, you can do UV, but it will take time, so don't, be fast. Let's do one more. We have one more kind of question. All right. For this question, you have to again find dy by dx. Find y dash. So same thing, log y log. See, as such we can directly also differentiate. It's not a problem. It's just by taking log, this problem of e you can eliminate. Okay, so let's take log. So log xy is equal to log e raised to power x minus y. Power will come down, so log xy log e x minus y. Okay, x minus y log e. The reason I wanted to discuss this method, I could have done with directly uv, and this one is chain rule only, but log e. Okay, if we don't write base, what is our base? E. Now how do we get the value of this? What should be the power of e so that we get e? Okay, so e raised to power something is e. What should be that something? That's 1. So log e, remember that log e is 1. So this is 1. So basically log xy is x minus y. We can use the property of multiplication also. Log ab is log a plus log b. Okay, splitted the multiplication in addition of log is equal to x minus y. Get the whole expression on the left, or your call, you can directly differentiate also. Get the whole expression of x log x plus log y minus x plus y equal to 0, and let's use the same concept, dy by dx partially with respect to x upon partially with respect to y. Negative again, bad habit. Write it here. Negative partially with respect to x. Log x differentiation 1 by x. This was log y. Log y, it's a constant and it's alone. So constant differentiation is 0. Minus x differentiation is minus 1. Y differentiation is, again, consider it y to be constant, so 0. Upon again you have to do the same thing with respect to y. So log x is constant, so log x is also constant, so differentiation is 0. Log y differentiation 1 by y minus x is constant, so differentiation again minus 0. Y differentiation is 1. Wow, very easy expression here. So this is 1 minus x upon 1 plus y upon y. So even if we manipulate this, what can we get? Y upon x, 1 minus x upon 1 plus y, or y plus 1, whatever you want to write. Okay, y upon x, x minus, there was one negative also, I forgot. So because of that negative, now what you can do, you can change this sign of x 1 minus x to x minus 1. So I'll write that. Okay, so with that negative, it is x minus 1. I have taken this negative and multiplied with this bracket. Okay, so that's your answer. Okay, so even though questions could be lengthy, but you can solve it in a very quick manner. That's all about logarithmic differentiation. Okay, I think I'll end the session here. That's it. That's the maximum you have to understand regarding logarithmic differentiation. I have discussed the questions in which equations are given and you have to find y dash. I have directly taken the questions in which y was given and you have to just consider your y dash accordingly. Okay, so remember when to use this: variable raised to power variable, or you have multiple product terms and square root, cube root, something like weird powers of your function. Okay, like in this one, like this, multiplication and powers are also there, so multiple things are happening, take log. Okay, all right, and that's it. I'll end the session here. Okay, see you in the next class. Good day, everyone.